The following content has been provided by RWTH, Aachen University.
So, hello everybody. Welcome to the next lecture. And today we're going to talk a little bit about basically three different topics. I will give you a demo about how to build complex input structures. Philipp already showed you a couple of weeks ago how to use auto layout, and I will tell you a little bit how to make it a little bit more responsive and how to do some interactions using like a complex table view with more than just table lines. We also talk about closures, which is a concept that is widely used in Swift, and Philipp will talk about this. And I will talk a little bit about animations, how you introduce new animation styles if you have custom widgets or you want to use animations. And for this one, we actually need closures to work this out. So just a reminder, seminar meetings are starting next week. So be ready, the MapKit group and the ClassKit group next Monday, and the CloudKit and the WatchOS team next Tuesday. So next week we'll have just 1 hour lectures, and directly we have the seminar topics, 15 minutes preparation talks for these things. For the seminars, again, just to make sure, so 20-minute presentation plus 10-minute Q&A session. And the deliverables at the end, we want to have, like, you don't have to directly send us, but sometime during the seminars, we want to have the slides and your code that you produce. So if you have created demo code, you should have a documented demo code so we can give access to everybody else. So as I already said, so it should have an introduction, should have a rough structure of the framework that you're using or the system, and then some kind of demo that demonstrates how to use the system. But we will talk that in individual groups starting next Monday. So Philipp already gave you like an introduction or a very long demo on how to use a table view controller. And I will extend that a little bit more by just showing you how to don't use only lines or input fields, but text input, but how to use more complex structures like the state picker, or how to use the switch buttons in a way that makes the interface quite more responsive, or a little bit more smarter, that the users don't have to like do everything on their own. So I will demonstrate this in this application. This is basically registration for a hotel form, where you can have, when you can select a new guest want to register, so you can check in, can select the check-in out in and out date, and can select the times and how many people. If they want to have Wi-Fi, and you can actually set the rooms. So basically, we have two table views with like data sources. So the registration has a data source, and this also has a data source. They are dynamic table views, and this is basically a static table view, which we will fill up with some information and how we can deal with that. So to show you how this looks like, I will not write the entire program. Most of the stuff is already there because that will take a lot of time to prepare this. So we'll just show you a couple of useful information or useful functions that you can make it a little bit more responsive. So for this one, we switch to Xcode. So this is the project, and basically I will just go briefly over the navigation, over the storyboard. So the navigation control is the first part, and then we have this table view content, which is used for the registration here, and the table view controller. So if you hit the plus button, a new navigation controller is clicked here, and this contains basically two views. The first one is this registration view. Let's see if I can grab this. No, I don't want to move this one here. So, and this is it. Okay. Oh, it's lagging. Nice. So here is the fixed thing, so it's designed in a way that we want to use this. And here we have another table view, which dynamic content. So we'll mostly focus on this part, and let's see what happens now if I start this. So I can click the plus button here and set my first name, so Simon, and this is my email address. So, and then I can select the dates, so typical interaction. So, however, this is quite uncomfortable and it's not very useful because I don't want to start in 1936 or something. So it should be something set to a specific date, and maybe I don't want to see the entire content of the screen the entire time because I want to make the picker expand or close up when I use them, because now most of my screen is basically blocked by these two pickers, and I would have to scroll down to see the other parts of the code. So why is scrolling not working? So, oh yeah, here you go. So this is the second part. So how can we make that the pickers actually set to a specific date, and how can we make, for example, that if I set a date in this particular picker, that the other picker also sets to a date which is actually after this date, because that doesn't make any sense to arrive on a day and leave a couple of weeks earlier. So how can I combine these things as a first step? So for this one, we go into the view controller, which is, so this view controller is basically in charge of this entire screen that I just showed you. So we'll just uncomment code because it's way faster and quite easy to see. So the first thing I want to do is I want to set the date to the current date, or to a specific day. And this I can use the date construction, which is a class which represents any kind of date information that you can have. So basically what this date is doing here, and if you initialize, it is specific on the exact time frame when it is created. So when it created at 12 p.m. today, it will be set to 12 p.m. today. You can update this later on, but as soon as you initialize it without any parameters, it's set to the current date and the current time. And then you can actually define certain things. You can say it should be set to a specific time frame, should set to, like you can add time, which we'll do later on. However, when we start this one, so this is basically an init jump, and it initializes for when I start this, and this basically makes sure that the data sets are set to the current date. So this is November. Oh, this one is not updated. All right. Let's see that later. So this is basically to set this up. So now we want to make sure if we have here a date, let's say I set it to tomorrow, that this picker also reacts to setting something up here. So this should be set to some day which is later on this thing, and should be dynamically updated when I set it to November 15th. It should be set to date afterwards, so it should react to this one. For this one, I created a function, and which I will call every time I update the picker. This is the function. So this is the checkout date, and I'm basically saying, okay, the minimum date, so it should be the initialized date, should be set to checkout date, getting the data set of this one, and adding a time interval. This is a weird number, but this is basically 24 hours in seconds. So it's an arbitrary number, but you can do that on your own. If you want to set it, for example, should be this, people should stay for a week, then you can multiply this even further. And then I define the specific date format here, and then I basically can set that. And now what I'm doing is here, I have an IB action defined for this case, as you can see here, and this is basically triggered every time I change something in the picker. So the picker is not like a button that reacts to just one click, but it reacts basically to every time you do something. So every time you do a movement in the picker, this function is called. So if you swipe through this to picker very fast, this function is called a lot. So this is quite useful for updating the UI, but at some point you have to be careful if you do a lot of computational things every time to change the picker. Yeah, it could go, your system can go very slow because, yeah, it does that a lot. Especially when you do fast swipe movements, it calls 100 times a second or something. So let's put that in there. So now it's basically updated, and I've set this to this date. You can see, okay, the other picker is directly interacting in the same way. So it's updating to, let's say, put it to a different year. So it's basically reacting to what I'm doing in a similar way. However, since we want to have that directly from the start, I need to call this function once at the beginning of when the view is updated. So the second view, the second picker is actually having the correct date from initializing. So as you can see here now, so this is already set to 24 hours later. Okay, let's move on. So what we would also like to have is that we don't always see the pickers. So maybe we want to minimize the pickers at some point, that we can actually see the second part of the interface, which is down here. So this part of the interface. So we want to have this method that you'll see in some time, that you can actually expand and close up the pickers to save some screen space. And for this one, we need to implement, first of all, have a method to allows us to select and deselect the value. So we want to have, like, we want to click, let's say we want to click on this part of the interface, and at this point when I click this, the picker should expand or should close. So we need to know where it is. So for this one, I defined two variables here, and these are basically an index pass is basically saying it's an index for a specific row in the table. And as you can see here, our table consists basically of multiple sections. So this is the first section up here, and this is the second section. I want to have basically selecting the first element and the third element, because this is element number 2 and this is element number 3. So, and this is section number 1. So these variables are basically defining this part and this. So what I need then is also have a state changer that actually tells me if the picker is expanded or not, because I basically want to flip a Boolean information that allows me to check if the picker is hidden or not. For this one, I basically created 2 variables, which I can just flip, and at the same time, when I change the variable, so the date picker should be shown, at the same time, I make the GUI element hide. So basically, every time I set this value to is hidden to true, the GUI element just disappears. So it will not be rendered, and it will be doesn't react to interactions in this case. And with this, I can basically disable the GUI element quite easily without having to have another function. So basically, this is my variable that I will choose for checking if the date picker is enabled or not. I could also directly ask the date picker, are you hidden or not? Because it's basically a Boolean as well. So this would be also possible. So now I can flip, enable and disable the checkers. And now I have to check when the user clicks on one of these particular index passes. So let's go to this function. This is a little bit longer and it looks quite scary. But so this is basically this gigantic function here. I will go through that. So this is basically a function that is implemented in the delegate for the table view. And what it does, it basically gives me a callback every time I hit I hit one specific element in the table view. So it's a callback that I get from the table view. And what I'm doing is basically switching, created a switch case to identify, okay, is the index that I just selected, is that the one that I defined up here? Is that actually the row before the date picker? And then if this is the case, because I want to have, let's say, okay, check this, and then I'm basically flipping through these different pickers. So every time I click one table, I'm showing, or one row, let's do it like this. If I click this one, this should appear, and this should be hidden. So I can flip between these two. They should be not visible at both at the same time. And this is basically what I'm doing with these false statements. So for example here, if the date picker is showing, the in date picker is shown, I will make it invisible. And if it's unshown, I'm just flipping the switch. And with this one, I can update this. However, what I need to do here is I need to update the table view. This is something that you have to trigger. If you change something in these in a table view, you have to update the table view so that the delegate can react to that and render basically an entire table again. And this is the other case, but it's essentially the same thing. So very long switch or some code, but it is actually very simple. So let's do this one. So with this one, now you can see I can hide these elements. However, hiding is not the only thing I want to do. I want to make these table views very small, so they basically fade away. So I'm hiding the element, but I want to make the space quite small in this case. And for this one, I can also use this function here that basically also gives me the information. What I'm doing here is basically the same thing, and I'm basically giving information about the table height, how high one table cell element should be. In this case, it's usually the typical height of a table view is 44 points. So this is the normal definition. So height is 44 points, which is depending on the retina resolution. Yeah, the size, it's about 8 millimeters, isn't it? Roughly something in that area. So 8 millimeters is the minimal size that you have in a table view. And the date picker is usually is basically multiple of these columns, so they are 260. So what I'm doing here is, again, I'm checking again if the variable is true. If the date picker should be shown, I will expand the size of that cell to 216 points, and if not, I would set it to 0. So this gives me the height of the different table views. So let's enable these functions at the beginning. So I have these date pickers, and now I can basically extend them. And this is usually animated when you check this, so that you don't have to even think about how to animate this in a way. And now I can set a specific value, and this is automatically updated. And if I click now on the next one, so this is updated quite easily. So with this one, you can actually check for every value if you want to expand or show that. So this is a very simple way, and as you can see, I reduced the size of my entire interface to let it fit on one screen. So this is the iPhone XR, so the size is quite large, but if you have an older version of an iPhone, for example, let's say an iPhone 5 or 6, the screen space is even much smaller, so you would even see maybe half of the screen when you have that expanded. So it's always a good thing if you have an interface that you can actually shrink down to a certain size so it fits actually on the screen, so people can actually see what's on there. So the next thing I want to do is to implement these switch buttons here, so you can actually add uses here. And for this one, it's a very simple function. So what I did here is basically have a number of guest function, which takes the number of adults labeled. So this is this label here, and it is set to the number of adult steppers. So these steppers are not just two buttons, but they have an internal count. They can count on their own, so they have an internal stepping, so you don't have to think about what value it is, but you can actually use just a count, so they can count on their own. That's the benefit of having these steppers instead of just having a plus and a minus button. But the plus and minus button, you would have to define a variable and see what's the current count. But with this one, you can actually just take the value of this. And what I did here is basically trigger these steppers every time, or this function basically trigger every time when one of the steppers is selected. So, and this one, this is very simple. You can just put this certain value, and you can actually define in the settings how much the value range of these steppers. So you can actually set them to minus specific value. So let's see about this Boolean operation, this Wi-Fi or not. Here I don't have to write any code. I could just, when I create the registration, I could just look at the state of that particular button and say, okay, this should be on or off because it's Boolean information. So the next thing is basically I want to select a room. In this case, I have 3 bedrooms here. Let's take the queen's bed and do the selection here and then go back. So this is basically a segue when I will transfer some information. However, as you can see, this label is not really updated, and I want to set this to a particular value in this case. And for this one, I basically prepared the segue here, as I showed you before. So basically, this function is called every time I click this button, so the segue of selection room type, which is the segue between these two views, is triggered. And then I'm basically saying, okay, the destination view controller is this particular table view controller for the room list, which I created. And then I'm saying, okay, I'm the delegate, this class is the delegate for this one, and this should be setting to a specific value. So this should work so far, so I can have a callback into the different controller and a callback when I set something going back. However, I need to also implement this did select function up here so I actually can use the room. So I have to react to the information that comes back from the segue. So this is the update room function that I will show you now. It's also very simple function. Where is it? Basically, this one here. To get rid of this one. So update room, it takes the room type and it basically sets the room type label to the name. And the room is basically a struct which contains all of just these three values, for example. But I'm taking just the name for this one here. So, and since I want to update this at the beginning, I'm also starting, okay, update the room times and update the numbers of guests at the beginning so I can have the interface working on this as well. So here I have, let's say, Philipp. Is that your email is? Check in with multiple people, set this to a specific value, can set this to this, to the size, and then I can create this, and this is basically done. And how I create these objects is quite simple. At the beginning, basically, when I return these values, I'm basically initializing this from just the interfaces. So you can see here, I'm taking the first name from the text, from all of these text fields. I take the picker dates just directly from the UI elements, and the number of people from this stepper information, and the Wi-Fi setting is, as I said, it's just the Boolean information, and from the room type, I'm basically taking the variable that I got back from the segue using this room type. Okay, but this is just a few hints how you can actually look, how you can make an interface a little bit more responsive and or a little bit more dynamic, and then we will continue on with Philipp talking about closures, and then I will show you how to use closures using animations.
All right, closures. Closures actually is the last topic I think that we're talking about for the language Swift, so construct there. And closures are used throughout the whole documentation that you see from Apple, and a lot of the frameworks extensively use them. And what closures are ways to contain blocks of code in variables or pass them around and use them throughout your app. So they're similar to what Objective-C had with blocks, and Java has with lambdas, and I think C# has a construct. I'm not sure how it's called there. But like I said, there are self-contained sets of code that you have. And you've actually seen closures already, because the functions that we use in classes and everywhere around, they're actually a specific set of closure, a closure that is named, that has a name. And the closures, usually when you refer to that, are unnamed functions or anonymous functions that don't have a name. So yeah, the different closures that we have the functions in our classes. You can have nested functions that are inside your classes, inside your functions, a nested function in there that is only valid for that time, or you have your unnamed functions, anonymous functions closures. And the syntax looks something like this. So it is similar to what you already know from functions. You have your parameters here, and then the return type, similar to what you had before. But now the braces here are starting at the beginning. So in the functions, you have those the curly braces mentioned behind the return type, and then you had your code between them. But here they are set in front. And then you have the keyword in to separate the definition of your closure from the code, from the statements that you make. So best look at an example for that. Here we have a function that sums up over an array. So not implemented out, but it would take here, you have a function that takes an array of integers, and you have your total, have the code that sums those up, and then I return that code or that total. And to call that, I call the name of the function, set the numbers, and pass over the array that contains the numbers that I want to add up. So similar thing as a closure. You have here your constant that you assign the closure to, and then you specify here the parameters that are passed to it. Again, a array of integers. Specify the return type, and then you have the in keyword. And then you have, same as for the function, you have here the code, set the total, sum it up, and then return the total. So all that is behind the in keyword is the same as what is in the braces, the curly braces for the normal function. And to call that, the same as before, you just call the constant that you specified, the name, and then inside of that pass over the array of integers. And here you don't have to specify the name that you would have for a function, but you can just pass it over and mention it there. So the different types of closures that exist are also similar to what you already know about functions. So there are 4 different types. So the first one where you have no parameters that are passed to it and there is no return type. And so for example here, if I would just want to print something out, I have my parentheses there and can specify void as a return type, but I could also drop that and just have the braces in, or even just the print statement for that. Then you have the case where you have parameters, but still no return type. So here, if I pass over a string as the parameter, and I can just print that then out. And again, I could also drop the void in the definition of the closure. I don't have to write it out. Third type is where you don't have any parameters, but instead you return something. So think maybe of a random number generator where you just, okay, I want a random int. You don't have any parameters, but you return an int and just have then to call return as in similar function or normal function. You can't, in this case, drop the parentheses here. They are necessary to specify the closure. And then the last method or the last way is the way you have parameters and you also have a return type. And it is, again, similar to what you already know from functions. You specify your parameters within parentheses, specify the return type, and then you can do whatever you want with the code there. Like I already said, closures are very much used throughout Swift, and there's even a way to how do you make it simpler to call them. So a way where closures are often used is when you pass them as an argument to a function, and then the function itself can rely on that functionality that you provided while calling that function. So, and if you pass over a closure as an argument, there's the concept of trailing closures that makes it just a little bit simpler. So let's consider this, the sorted method of an array. So what this method does is it sorts your array based on a comparison or based on an order that you provide. So think of songs here. If I want to order them by their star rating, the method takes a closure. So there's the sorted by method and has a closure that takes two elements. Both are of the type that the original array is. So here tracks, and returns a Boolean. And the Boolean is basically specifying whether one is in front of the other or not. So here you return the comparison between those two star ratings. So first track star rating smaller than second track star rating would return true. And the sorted method, we don't have the implementation of that, but what it will likely do is take pairs of them, compare which should be in front of the other, and repeat that over and over until the whole array is sorted by that way. So here we have the function. It only has one parameter that is passed over. And that in the end you have here this weird looking curly braces and parentheses closing. The parentheses belong to your sorted method there. So looks a little bit weird. And how you can make that simpler is by just dropping the parentheses. And even the by keyword is then gone. So you just have sorted, you have your curly braces in the beginning and the end, and you can just write your closure then directly after the name. You don't have to write the parentheses anymore. Similar, if there are multiple parameters that are passed over, and the last of those parameters is a closure, you can also drop the brackets there and just have the closure trailing behind it. So here we have a method that takes two parameters. One is a string, and the other one is a closure. A closure that takes an integer and returns nothing. And instead of having all of that within the parentheses, you only have here the URL, similar to what you already know, pass over the string, but then you close the parentheses and just have the closure in the curly brackets behind it. So it's simpler to read, makes it a little bit easier. The other way works fine as well, but you will see, or when you do that, looks sort of weird, and you have trouble seeing where actually the list of parameters ends and where the closure starts. And for the thing with closures is a lot of the functionality you can do in many other ways by just using loops, other functions. But closures you tend to use more the more you know the language, and helps you get along. And when you're using closures, there are also a couple of ways how you can simplify them. So again, let's look at the sorted method. And there are a couple of ways, I think it's called syntactic sugar, that you can do to make it even shorter. And it's then when you know the code, makes it simpler to read. But in the beginning, I would advise stick to the longer notation. It's clearer. And then once you get more proficient with that, leave stuff out. And yeah, it makes it simpler. So like I said, we have here our sorted function, takes two parameters, has a Boolean return type, and then just returns a comparison and to help the array how it should be sorted. So the first thing that can be inferred, and as you know, well, Swift very much on type inference and making stuff there simpler, is it knows, okay, I get two parameters and I'm returning a Boolean. And that is by the definition of the function, of the closure and the parameter that is passed over. So the first thing that you can do is just drop the return type. You don't have to mention it here anymore, because that is what the definition of the closure already tells you. The second thing is, it knows it takes two parameters of the same type as the elements in the array. So you can also drop the definition of the or the naming of the parameters, and instead use a placeholder, so $1 and $2, for example. So you can drop this part where you specify the names of the parameters and instead just use placeholder $1 and $2. And that also, yeah, you don't have any definition there anymore, so you can also drop the in keyword and just have the comparison then that you pass over to the sorted method. And then the next thing is, if there's only one argument in your closure, that is returned automatically. So you don't even have to use the return keyword anymore, and instead you have just the sorted, and in curly braces behind that, $star rating smaller than $1 star rating. And that makes it a lot shorter, but if you don't know what is all coming along with that, what is all left out, it will get tricky, or it is a little bit tricky to understand. So I would advise starting, well, at the top, and then the more proficient you get, leave out things, make it simpler, and then when you know of that, it's simpler to read as well. Any questions about the simplifying of this case? All right, then we'll continue with a couple of examples of methods on arrays that use closures, and they can help with a lot of the actions you do with arrays and that you want to take. So the first one is what's called mapping, and mapping is basically applying a specific operation to all sets or all elements of the array. So here it is written using a loop. So I have an array of names, first names, and I want to have an array of full names that just have also the last name. Last name in this case all has will get called Smith. So what I could do is just have a for loop over my array and specify the full name as the current name plus Smith, and then append it to the array that I want to have where all the full names are in. So that's totally fine, would work. But I can also use the map function of an array. So, and the map function takes a closure that has just the one parameter name and returns a string in this case, and I just return that name plus the Smith last name. And that is the same as the what all the function there in the beginning does. But again, what I could do is, well, simplify that based on the rules that we specified, and I could do the whole thing in a short version that just has, well, okay, take the element, append Smith to that, and this will create the same array as I would create by using this loop here. And the type of the array here depends on what you return here. So it doesn't have to be a string that just changes the type in there, but I could also return the number of letters in that name or stuff like that, and then the a returning array would be an array of integers. So I can map it to different types as well. Next one is filtering, and filtering, very straightforward, takes the array and just returns a set of elements that are sufficient for a comparison that you hand in. So in this example, again, with a loop, is I want to have an array that has all the elements of my original array that are less than 20. So specify here the array that I want in the end that has the numbers less than 20, and I go over every element in my original array, check whether they're less than 20, and then append them in that case to the new array. And with the filter function, it's again that I have here a closure that I pass over to the filter method, and takes the current number and just has a check whether this is fulfilling the condition that I have for the filter, and if that is true, it will be added to the filtered array that I now assign to my less than 20 array. And similarly, I can simplify that I just have here the comparison of the element to my rule. So I just have $0 less than 20 to simplify that. And the last one is reduce. And what reduce does, it reduces the whole array to one value, to one element or one summary of the array. So here, if I want to have all of that, all elements added up, what I could do is I have my array of numbers, and I define a total, and then I iterate over every element and add the current number then to the total. And the end total is the sum of all the elements. Reduce is a function that takes two parameters. One is the starting value, so what is the initial value, and then a closure that has the current total and the new value. So the current total is then the result of everything that happened before the value that is now processed, and the new value is the value that should be addressed next. So we have in our closure two parameters, the current total and the new value, and it returns here an int if I want to add them up, and I just return the current total then plus the new value. So for the initial run, current total would be 0 and new value would be 8. So I just add them up, and in the next iteration, the current total is then 6, new value 8, the new value is 6, and I would just add them up and repeat that over and over until every element of the original array has been used, and then the total is the sum of everything that we have here. So again, I can simplify that by just having here the starting value and then what the adding operation by having the first one added to the second parameter that I'm passing over. So it's a simpler version there. Any questions about these three, if you take the sorted 1-4 methods for arrays in, everything clear? Again, it's something that you can do completely also with loops. Absolutely no problem with that, no downside as well. The functions just help it to make it a little bit shorter, a little bit less verbose, and it is something to keep in mind, comes in handy quite frequently. So the last thing that we want to address with closures is what's called capturing values. So closures are very often used to pass blocks of functionality around. And what closures do is they capture their context. So let's look at it with an example. So here we have a function that should create an incrementer for a specific amount. Meaning I want to get a function back that I can just call, and it has an added value. If I call it again, it has the value added again. So what I have for my increment, I want to specify the amount, and the return type is then actually a closure. So closure that takes no argument but returns an integer. So, and I specify then a running total, so starting at 0, and then I create a function for my incrementer that adds the amount to my running total and returns that. And the return type of this function is then this incrementer function that I'm creating here inside. So how I would use that is I assign my closure to a constant here, And so I create an incrementer for an increment of 10, meaning that I want every time I call that the running total to be added with 10. So, and if I call that the first time, the total is 10. If I call it second time, 20, third time, 30, and so on. So why does that even work? Because, I mean, the function or the incrementer that I return here, it doesn't have a property or value for running total or even the amount. And that is what meant by capturing values. It captures the scope that is around. So if I use the running total, it has a link to the running total that is specified outside of my function here, and also can use the amount that is also defined outside of that closure. So that means that the increment by 10 here has still the same running total that was for the first call already set to 10. So that is why this now shows up to 20. And closures are reference types, so they keep the reference around. Meaning, if I have let's say I'm creating a new incrementer that is now for an increment of 7. This has a different running total because if I call that method again, I have a new variable running total set to 0, and my incrementer that is incrementing by 7 uses that reference. So if I increment by 7, I'm at 7 and not at 37. If I would call it directly after this one here, it's at 7. But if I increment then by 10 again, it still has the reference to its original running total, so it starts by 40. But now if I create a new constant and set it to my increment by 10, it has the same scope, the same reference to the running total. So if I then call also increment by 10, it doesn't start at 10, but instead continues counting up from the 40 that we have before, so now it's at 50. And this whole concept of keeping the scope, keeping the elements around is very handy if you pass those closures around, because they can use values and use elements even if the original scope has passed. So think of it here, that scope of this function is gone when the function has been returned. But the closure that has been returned still has its link to the running total, to the elements that it needs. But it also has then the tricky element. If you have a closure that is referring to something of the surrounding context, and that is an object, and you have basically then a link between your surrounding object and the closure and back, it will often come to the case that then those are kept in memory indefinitely because they keep a reference to each other, which keeps both of them alive. And that is often you see that if in your closure you're referencing to self, and in that case you need to think about, okay, how do I break up this link if I don't need them anymore? So how do I keep them not retained indefinitely? But that is something that goes a little bit beyond what we're talking here. But just keep in mind, if you're having a closure and you reference to self, think about whether you have to do some manual breaking of that link or a specification of what should happen if one of those elements are done, basically. Should they be kept? Should they be released from memory? Any questions about retaining values or closures in general? All right, then yeah, keep them in mind. It's one of the topics where everything you do here can be achieved in other ways, but for elegant code and simple code, you can use them. And animation is actually something where closures are used extensively. And yeah, Simon will continue with the animation.
Okay, let's talk a little bit about animations, and this is a crucial thing that you see in most of the systems, because animations are usually used to provide attention or indicate what's currently happening. And if you, for example, if you would have this on-screen information and you would swipe between these different views of your first home screen without any animation, people usually get lost because they don't know what usually happened. So animations helps the user to understand what's currently going on. For example, if you zoom into an application, where's the video? Oh, there's everything. Oh, right. So you always have these animations. The user have the understanding of what's going on, and that you have a feeling. Okay, now I'm going in this folder. Now I'm going into this application. Now I'm closing the application. I'm switching to a different view. So this also all happens with animations, and these are some built-in animations. And usually, what you do is you can use them as well by including your animations in your own applications. For example, the typical one is in music application. When you play a song in the Apple Music thing, the icon of the song grows a little bit or slows down. So it provides a little bit more insight into how these things. And usually what you can do, you can use animations on UI views. And maybe you remember basically every object that you have in your iOS application is a UI view. Each button is a view. Each label, each table cell is a view. So you can basically animate anything you like. And typically, images are something that you usually animate for rotating them or making them pop up or something like this. And the typical animations that you can do is you can have change the frame size, you can scale them up, mold them down, you can change the bounds of these things. You can transform then the center and alpha values, so you can do alpha blending in a very simple way. And all of these things. So to do animations, there are usually a couple of calls, and a typical one is the animation with duration, and you basically define what should happen. So for example, if you have a window that you want to do, you want to scale up, you basically use the animation thing on that particular window. I will show you a demo later on. You basically define what should be the final state and how long should the animation take. For example, it could be animated. Then you can also do delay animations, and these are actually closures that you use in this case to combine these things. So I will show you an example. For example, this is a very simple animation. So this is my UI. I want to animate that in 2 seconds, and the view should have a certain alpha value, so it should go a little bit darker over time. So with this one, you can actually use closures in this case. And another important thing is you want to concatenate or have a sequence of animations. And for this one, where you have to wait for a certain animation. Because what happens if you create this animation for a couple of seconds, the code is running on a different buffer, so basically it creates some kind of an loophole, and you cannot really wait at a certain point until the animation is done. What you then do is basically use closures to attach a piece of code that is executed when the animation is done. Example, we'll show you on when you do an animation by moving an object and then you want to move it to a different direction, then you can use closures to actually update that one. So with this one, I will give you a couple of examples, but you can actually play around with this quite easily because you can actually do or test all of these animations using the playgrounds, and I will show you how to do that. So for this one, I'm just creating a new playground, a little empty one. Let's do it. Replace this playground. So this is my playground, and I need this second view to actually see what's going on. And to do that, the first thing is I have to import playground support. So this is basically a run loop that allows me to use some specific animation style, so I can actually add views to the playground. So let's define live view frame. So this is basically the size of the it's a CG rect. A CG rect is basically a rectangle which has like a starting point and has a certain size. So this is basically every frame, every view has this kind of rect. And then let's create a view. And this is a UI view with this particular rect. So basically it says that. And then I have to attach it to this playground page current live, and this should be the live view in this case. So here's my view. This is the thing I created. So this allows me to actually give a visual view inside the thing. So here's the typical thing that you usually see in the playgrounds already. So the information about the certain variables, but I can also use it to basically draw some code in a very simple way. You can also run SpriteKit in this thing if you like to. So this works in a very similar way. So let's do the first thing. Let's just create a small rectangle and a certain size. Again, I will do it a rectangle. Let's do it 100, 100 when the other one is 500. And let's create a square, which is representing just one of my buttons or image views in this case. And let's make it, the typical background color is usually black. So if I want to see it, I want to use it for green. So basically this is the color green. And I'm now saying, okay, my live view, which is currently displayed here, should add this sub view, and this I'm using the square for this one here. So here's the square. Looks a little bit weird. There's a little bit difference. Why is it in the top left corner? Do you have any idea? As you can see, I defined it from 0, 0 and have the size of 100, 100. This is, yes. Yeah, this is a little bit confusing. iOS applications or iOS systems have a different origin. Usually you have an origin in a window in a desktop environment, which is in the lower left corner, but on iOS devices, it's in the upper left corner. So basically the y-axis is inverted. So as more as you go down, the y value will increase. So this is something that you have to get used to. You can actually update, you can change the origin for some applications. For example, SpriteKit allows you to define the origin for every view. However, if you animate just a normal button, you always have to have the origin in the top left corner. So this is something that at the first time it's a little bit confusing. So let's do the first animation. So UI view, the animation. Oh no, this is the wrong one. So what I'm doing here now is first just use the normal animation, and I'm saying I want to have it in. Let's do 2 seconds, and I'm adding basically in this case a block, or not a block, but closure. And in this closure, I'm basically defining the end state of that animation. So in this case, say the square should have the background. Let's put it to orange. And that's basically it. That's the entire animation. Let's see. Oh, I have to run the animation here. How did I run the animation? Let's see. Where's my cheat sheet? Yes, there's the code I need to use. No, it should actually work directly, shouldn't it? Oh yeah, I had to restart it basically. So this is basically running the animation using that part. I can also have multiple animations there. Let's say, okay, I want to change the color in the same time. I want to change the frame, which is basically the rectangle I define. And put this to, let's say, 200, 200. And also change the size, not to this one, but to this. So I have 2 animations combined together. However, now they're running sequentially, so I'm running at parallel, so I cannot have different timings of these things. So one way, how could you think it could be solved? I could just copy that and do a different animation at the same time. So let's do this. Let's copy the animation again and say, okay, I want to have that it changes back to green afterwards, and it should go back to this original square like this. So like this, and let's run this. Oh, now it runs the entire, just this part. So the position did not change. So what happens here is because they're running two of these things run in parallel. And this is something because this part of the code is executed at the same time as this part of the code is executed because it does not wait for each other. So how can we do that? So let's get rid of this one first. And for this one, we can actually use, what is this? Okay. Animation, and instead of doing just the animation with, as we did, with just an animation, we can actually say, okay, I want to have a complete handler. So something should happen when I'm done with the animation. So the first part is the same. Let's copy that from here. So taking this block here. And then I have a completion handle that I can also use again for example, triggering an action, or I could use in this case for run a block in, and then I can basically wait. So let's put it back to something is wrong. No, I forgot. So where did I type wrong? Ah, let's copy that from this thing to show you what's actually going on. So this is basically, it does an animation, it changes the change, and then it goes back to the original position. So this is basically just a trigger. If I want to do another animation, I would have to include the same thing again. And I will just copy this from this one to show you the different results here. So I get rid of this part of the code and put this in here. So what happens here is basically I first, let's make that a little bit more visible. What I'm doing is I'm running an animation for 2 seconds, and it does update this to this particular position. And then after the completion handler is done, so after the animation is done, I'm running another animation that does the same thing again, does the other thing again. So they're running it like in a sequential order. So going back onto these things, and you can do that at multiple times. So you can also then, if you can see this, you can actually stack them. So you can put a lot of animations in a sequence and order them in a similar way. Because here again, I could also have an animation that also has a completion handler, and so I can have multiple of them together. And with this one, with these animation starts, you can actually then create your GUI in a way that has some kind of animation that makes it a little bit more visible for the user what's currently going on in a simple way. And as I said, UI view is basically everything that is visual on the screen, so you can basically animate anything. This is just very simple animations. You can also do rotation, scaling, shearing, so you can actually apply affine transforming matrices to every object that you have, so you can basically also do multiple things at the same time. And you can do a lot of different animations. If you check out what the UI view can be animated, and it's basically indicated in the parameters of a UI view, which parameter can be animated and which are not. So what the system is basically doing, it creates the animation on its own, so you don't have to do it. However, there are some parameters, I'm not sure which one. For example, if you use the isHidden parameter, this cannot be animated. It's just a Boolean, so there's no alpha blending. In this case, you would have to use the alpha blending of the view, and then at the end you would have to say, okay, now it should be hidden. Okay, this was a very short introduction into animations. And with this, we will conclude for today. Next week, Philipp will talk about AR kits. So we'll do a little bit of augmented reality systems, and Philipp will talk a little about Scene Kit, how to include this, and how to show you a demo. And then we'll have a meeting on on the seminars. Unfortunately, I cannot be here on Monday because I have an event which I have to attend. But on Tuesday, we have the last lecture before we start in the seminars where we will talk about web and how to crawl data from the web. Okay, this. Thank you for attending, and we'll see us next week.
This content was provided by RWTH, Aachen University.